You've probably heard a lot about things like knowledge, context, semantics, memory, ontology in AI these days. They're all separate topics in a way, but I'm going to bring them all together, actually, with this topic around the knowledge layer. And this comes out of working with thousands of customers over the last few years and seeing that there are a number of different patterns in which they take all of those things and use them in one common way. And that pattern is the enterprise knowledge layer. So here you can see a simple picture of apps, agents, tools accessing a knowledge layer that gives agents what they need from a data and knowledge perspective. And it brings together data from across the enterprise, you can see on the bottom right, all the different operational data sources, and on the bottom left, from the different analytic data sources. And now this isn't a lift and shift. The knowledge distinct from data doesn't mean everything about everything. It means let's pull up the signal from the noise and let's connect it up. Those connections are essential here. And then likewise, you can start small and then build up. So it's also very incremental. And if I look at the function, what's it doing? It's storing structure, context, and meaning. It's providing a uniform memory and retrieval layer for agents. It also bridges human and machine understanding. And this comes back to this idea of neurosymbolic AI, which is not new. It's a few decades old. But it's coming back with graphs in this different way of, you try to introspect a model or introspect a vector database, and those are unintelligible to a human being. Whereas with a graph, you can really understand as a human what's going on, and then you can execute it as a machine. And then it links and unifies your data sources and objects and stores data as a graph. Here are a few examples of this in action. So one is Walmart's People AI Knowledge Graph and Graph application. This is an agentic application usable by Walmart's 1.6 million or so employees that helps them navigate their career journey. So what does the graph look like? It's all the people, the reporting structure, the history of the reporting structure, their skills, how those have accumulated over time, what projects they've been on, what all the different open jobs are, and what their job requirements are. And it turns out that if you put those all into one graph, you can recommend someone's career journey simply by connecting the dots. It's almost like solving for HR by degrees of Kevin Bacon. And importantly, this then feeds a model, so there's a model in between the human and the graph. But the questions actually can be answered either by the model, by feeding it more context, or you can actually get an answer from the graph and run it deterministically. So you have this powerful optionality of running deterministically or non-deterministically. Here's another example at Uber, who has a different kind of graph. It's the rules graph. So Uber operates in 15,000 cities. They have different offerings in those cities. Those are called different things. There are different laws, regulations, as well as Uber's own reasons for varying the offerings. And those rules are stored and executed in the graph. And I brought one more example from a major gaming company. This is one of the largest gaming companies in the world, where you can see an API, a conversational AI accessing an API layer, accessing a multi-agent system, and then using the graph as a semantic layer. And semantic layer here means taking business terms and concepts, the relationships between those, and then mapping those to physical infrastructure and down to data infrastructure and where you can find the data. So agents use the graph to get a map of where to go in the enterprise to find data. So these are three different kinds of graphs, and you could say this is semantics and ontology. Earlier was the domain graph. You have a rules graph, which is a form of memory, procedural memory. And what they have in common, and the key core insight behind why these people chose to build the systems in this particular way, is that they saw that their data either showed up as a network, so in the real and digital world that AI needs to engage with, it tends to show up in a few ways. It can show up as a network. Computers are networks, social networks, communications, biology, ecology, transportation, and so on. Or is a hierarchy like the Walmart HR example, which is actually multiple hierarchies and journeys, and then likewise with customer journey, patient journey, and the like. And so if you can choose to represent those in tables, and in fact that's been the dominant way over the last few decades, but there's a newer way to look at data, which in fact, as of 2 years ago, is an ISO standard. So for those of you who might not be familiar with this, for the first time in nearly 40 years, the International Standards Organization blessed a new data model in the database space, the property graph data model that represents data like this, the way we're talking about, for dealing with data that shows up in the real and digital worlds as networks, hierarchies, and paths. Now, why do you need a new model? Why isn't it enough to deal with what you've got? Well, let's look at what you've got. You can use a foundation model, but they've been trained on the world's data, not on yours. Okay, well, then I can train my own small model, but that's expensive. And then let's say I get over that. The minute I train the model, it's already out of date. And then everything I've trained my model on becomes fair game for answering any decision by any agent for any purpose. And we know that you have all kinds of rules around access controls inside of an enterprise. It can also still hallucinate and lack discernment. And it's a black box. Data structured as static rows and columns is great. That's where most data is. And that's good for answering fixed and simple questions. But if my questions get super intricate and complex, and I don't know in advance what the next question is going to be, then actually this is where graphs have always shined. I've been doing this for more than a decade, and this has been the main reason for using graph technology. Now, I can look at other unstructured forms of data, but that tends to be difficult to mine and make sense of, and as I pointed out earlier, vectors are completely opaque, and it's arguably like a one or two trick pony. And then organizational data is spread across silos, so how do I bring the knowledge from across the silos so that my agents can share the intelligence of the entire company, not just what's in one system? Now, many companies have been doing this to the point where Gartner's gone out and said, look, this is a clear trend, and their recommendation to data and analytics leaders is they must redesign the data and analytics architecture to make the context layer the central brain for AI agents to deliver trusted intelligence. That's exactly what we're talking about here. Now, let's look at the requirement agents have of knowledge. Now, agents are highly interactive, so they can't just interact with a data lake or a lake house. They need a real-time system where they can have low latency retrievals, as well as update the system so that you can have a virtuous cycle of self-improvement. You also need to be able to store structured, unstructured, and semi-structured data, number 2. Number 3, you need to bring together data from across the silos. Now, your data lakes and lakehouses bring data together from across the silos, but at the expense of losing the connections between them. You're centralizing everything, but you're not connecting it. You need to be able to have a RAG corpus, and I would add a graph RAG corpus. And then you also need data access controls for exactly the reasons we were talking about earlier: corporate firewalls, security, privacy. So this is what agents need. Now, if I bring all that together, this actually answers all of that. This is really a zoom in of what we went into earlier. And at the highest level, you've got your data that's connected as a graph, your domain data, and that can be your own domain, that can be reference data that you get in from third parties. And then you also have the option these days of running graph queries against data lakes through technologies like Neo4j virtually, so virtual graph is on there. In the ontology bucket, I include the semantic layer. So this is everything around meaning, your business meaning, and then how it maps to where your data is located. This is like a business and a technology map. And then last but not least is memory. So conversational memory is just all the different texts and prompts. But then, much like the human brain, as part of the process of sleeping and memory consolidation, gives you long-term memory, which is what are the things that matter and how do they connect. Long-term memory tends to be best stored as a graph. Procedural memory tends to be best stored as a graph. Context and decision traces, which is another form of memory, likewise. So what's the role of a knowledge layer? This is a whole presentation that I've rolled up into one slide because we've just got a short amount of time. I've got some learning resources at the end. But number one, it's providing context for agents for better answers. I'll show you a link to a paper that just came out by the UK's Centre for Data and AI Innovation that complex, let's say a rich academic piece of research that shows that you get substantially better, I think it's more than twice as many questions are answered versus not, with 80% better fidelity, lower hallucinations, and fewer tokens. So very, very powerful. It can connect the silos. It can give you knowledge transparency and an option for deterministic processing. It can respect data access controls. And then, surprisingly to me, it can handle complex questions much better. I've had customer after customer come back and tell me that AI models do a much better job of answering a complex question expressed as human language using graph queries than using a relational query. And that's because the graph query language, GQL or Cypher, you might express a complex question as in 5 lines that's 200 lines in SQL. It's a much more terse representation that's nearer to human language. Now, what are the kinds of data concretely in the enterprise? There are 2 ways you could look at this. One is, let's say, a breadth-first or top-down view is the enterprise itself is a connected organism. So you can build a map connecting up the silos. The other one is bottoms-up. Here you can see you have the product graph, which is a product hierarchy. And out of that, you have all these different use cases underneath that are supported, recommendations, product pricing, inventory. But then that connects, if you connect that into the supplier data, you can do supply chain optimization, and so on and so forth. We saw the employee graph, career journey, et cetera, et cetera. And you can build these out incrementally. I don't have a lot of time to go through this, but I'll just flash it. This looks at the top AI use cases, just looking at data coming out of the top systems integrators and some of the top AI labs, mapped to the kinds of graphs that show up, mapped to the kinds of AI motions and process that are enabled. And you'll see things like multi-hop reasoning and agentic workflows in there. So drilling into reasoning, one takeaway I'd like to leave you with for today is that the knowledge layer isn't just a passive place where you store information. It can actually do various forms of computation. So I'm running short on time, and I'm going to zoom through these, but graph querying, which is different forms of pattern matching and filtering, graph algorithms, clustering, link prediction, and so on, similarity in search, GNNs, which is a topological vector, another kind of vector, and then graph visualization. And then the key advantages here are GraphRag, which gives you improvements in accuracy, multi-hop reasoning, which helps agents perform more complex tasks, semantic maps, map of the enterprise, decision traces, which is a whole talk in itself. I'll give you some breadcrumbs, and then memory. So I'll just leave you with a few resources, and then we'll drop. One is, I wrote this piece 2 years ago. It still holds up, introducing GraphRag. Next one just was published 2 weeks ago, describing the enterprise knowledge layer. So it's a kind of a prose description of this talk. Number 3 is this paper that I just mentioned, showing that agents using GraphRag versus vector only are 80% more truthful, answer twice as many questions, hallucinate less, and then it's less expensive. You use far fewer tokens. And then last but not least, if you grab this QR code, we've prepared a special landing page for all of you with some further learning resources. One of them is Andrew Ng was here today. There are some deep learning.ai courses, And then Neo4j has their own Graph Academy with lots of learning there. So I'll leave you with that. Thank you. Looks like I'm just on time. And thanks. And I'll encourage you to go and find your own graph.